The following video demonstrates the capabilities of the VisIRR analytics system. It has been applied to a set of 430,000 academic research articles. Users start by entering an initial filter. It may consist of a traditional keyword search query, a document's year, citation count, or authors. Here we query for the term disease. We find that there are over 2,100 matching articles. The system will only cluster and visualize 2,000 documents at once, so we limit our initial scope to only those documents with disease in the title. The system runs a non-negative matrix factorization-based clustering method and a linear discriminant analysis dimension reduction algorithm on the filtered documents to provide a way of visualizing documents on a 2D scatter plot. Document nodes are colored by their cluster membership and sized by their citation count. Conventional panning, zooming, and details on demand functions are available via the usual UI clicking and dragging actions. The Details dialog highlights words corresponding to the different clusters and shows a list of documents to scroll through when multiple nodes are queried in the scatterplot. Cluster labels, boundary ellipses, and citation sizing can be turned off to decrease clutter. Similarly, individual clusters can be hidden or emphasized in the Cluster Label panel at the lower left. Algorithm parameters can be adjusted in the Settings panel. Here, we turn off the Align setting, which minimizes differences between different scatterplot clustering and dimension reduction results. When we further filter the current documents to only those published since 2008, we get a new scatterplot. Documents appearing in both queries are linked by brushing. Here, we see that a spatially coherent cluster in the first query is much more dispersed in the new scatterplot. If we turn the Align setting back on and revisualize the results, the new arrangement is more similar to the initial scatterplot, making comparisons easier. In particular, the gene disease-related cluster is positioned at the top right in the Align scatterplot, as in the original, while the non-aligned scatterplot has it in the bottom right. The recommendation engine is a key feature of VisIRR. Here, we begin with the same initial disease query document set from before. The user zooms into an area of interest and inspects individual documents. After examining several nodes, we find a paper using PCA and Bayesian inference to help diagnose Alzheimer's disease. The user thinks this is interesting, so she rates the document on a 1 to 5 star scale. Doing so adds it to the recommended document list at the top left and triggers VisIRR to recommend related documents based on the rating. Recommended documents are added in a list at the left and also as squares in the visualization itself. Rating additional documents, this time a paper on using SVMs to do Alzheimer's diagnosis, refines the recommendations. Recommendations can be adjusted to reflect new priorities. Here, we update the recommendations to be only from the SVM paper, and change its recommendation type to be from the citation network, rather than the default content-based engine. Doing so appears to shift the recommendations to be mostly computing-related works. Using citation-based recommendations is useful to show highly cited papers, such as influential works or literature surveys. Note that these type of recommendation results would not be easily obtained by a simple keyword search, since the recommended documents do not necessarily contain specific keywords in common. Clustering the recommended documents refines our initial impressions of the recommendations. We see that they are specifically related to image analysis topics, such as facial recognition, object detection and recognition, and image segmentation and retrieval. The same exercise, this time using co-authorship recommendations, shows a different variation on the clusters. Note that most of these and the previous recommendations do not appear in the original keyword search list, making it much less likely that these other clusters would be found much less explored. Turning on Recommendation Edges links first-degree recommendations to the rated document. This view shows the rated paper authors publish in other areas like gene expression and source separation algorithms, which might be good candidates for further search iterations. Which in turn expands the user's search scope by following how the rated paper authors have published in other domains. Cluster meanings can also be explored by adjusting the label slider, which moves cluster titles between the most common and the most unique summary keywords. Thank you for watching a demonstration of the VisIRR visualization and recommendation system.